up makers, my name's Daly, and in this video we are going to be talking about what are hex files and what are .ino files, and then we're going to be talking about the difference, why we use them, and how we can actually produce the .hex files. So let's get started. So what are .ino files? Well, firstly, the name .ino comes from the end of Arduino. If you look at the word Arduino, you can see it's got INO at the end, so that's where it's derived from. But what do the actual files consist of? Well, the files are what's known as source code. Source code is any sort of sketch. We call them sketches. Sketches are simply programs. See, if I bring my mouse over, I can show you a program here. So this is called a sketch. Now, when we save this, you can see it's got commands written line by line. So you can see a sketch that contains commands to be compiled / assembled into a program, in our case, a hex file. So what I mean is that this file here, I've actually opened an Arduino.ino file. You can see it's called blink_hex_test. And when I open the folder it's in, if I bring that across, you can see it's an Arduino file. So that's an Arduino file. So the next thing on the list is with high-level programming language. Now what does that mean? Well, if you look on here, you can see we've got words and sort of commands that are similar to the human language. We'll go into the difference between high-level and low-level language later on in this video. But for now, high-level programming language and source code. Next we have the Arduino code itself. It's written in a hybrid of C/C++. And you can see the code itself is here. And you'll understand the difference between .ino and .hex files as we go on. So the core feature, or the core difference between a .ino file and a .hex file is that this can be easily edited. Here you can see I'm opening it in the Arduino IDE, whereas you'll soon learn that hex files are harder to edit. So why do we use .ino? Well, firstly, as I just said, they can be easily edited and updated using the Arduino IDE. Now, they can also be easily uploaded using the Arduino IDE, and they can also be verified and checked for errors. Now, this is good if we're prototyping or programming a new program and we want to slowly or continuously add features. However, like every file extension, it has its disadvantages. For example, when we start to use libraries or reference other code, when we open this program, it is required that the other code is referenced or is there. Whereas with hex files, you'll soon learn that as hex files are compiled, we don't actually need these. So the file itself is generally larger because it requires more code, as it requires the interpreter or translator, which we'll soon get into. But for now, the file is generally larger, and when we do upload it, it is slower, as we must firstly verify for errors, and then we must compile it every time we upload. Now, a lot of these keywords won't make sense to you, but after this explanation, I'm going to go through and explain what these keywords mean, and then we'll do a short recap at the end of the video. So now let's go on to hex files. What are hex files? Hex files are known as what we call object code. Now, object code is created when we compile source code, and we'll go into what compilation is and compiling and all that stuff. So as you can see, we've got the opposite. It is a low-level programming language that uses machine code and hexadecimal. Now, I've actually opened a hex file. Here you can see we've got the blink_hex_test.ino, and that is the actual hex file for the Arduino file we just opened. And you can see it uses a lot of values that, I can't really understand. This is known as hex, and it's written in the ASCII format. So you can see it's written in hexadecimal. Now this is because it has to talk to the microcontroller, so it has to speak in its language, and that's why we call it a low-level programming language, as it's written in machine code, not code that is similar to human language. It is compiled object code that we cannot edit, that is used by the microcontroller. So why would we use such code? Well, firstly, it is fast and efficient to upload Because it's already been compiled. We only need to compile it once. When we have this file, we can upload it as much as we want, quickly and efficiently, to the microcontroller. It is also smaller in size because it doesn't have extra metadata for the Arduino IDE. One of the key features about hex code is it can easily be redistributed because we don't have to worry about missing libraries as it is all compiled with the object code. It is like, here's a file, it has the settings required for a single microcontroller, because that is another problem. It is to do with accessibility. When we compile these programs, we have to specify the setup code. Oh, it is for the Atmega 38, or it's for this sort of screen. And you'll realize when you do the setup for your console that we adjust these settings, so compiled hex for the 8BitCADE will be different for compiled hex for the 8BitCADE XL because they have different processors for the screen, for example. Note that it doesn't need libraries or the other connecting files like we talked about with the .ino, whereas you need the other libraries for it to run correctly. However, it does have some disadvantages. We cannot adjust the code, and it is pretty hard to understand, as we just talked about, as we just looked at when we saw the code. You can see it's got numbers and letters, and it's difficult to understand. So what does all of that really mean? Well, I've said some key terms that we're now going to talk about. Let's talk about the difference and which ones we use. So, a compiler is for languages like C/C++. For example, Arduino uses a compiler for its high-level language. Now, what a compiler does is it scans through the entire code and it creates the object code, or the hex file in our case, that the computer can execute directly. So understand that the computer doesn't run the Arduino code, it runs the hex code that I showed you before. So a computer needs this sort of file format for it to run and understand. If we want to use this file format with words and closer to human sort of language, then we need a compiler to compile it. So then the computer can sort of understand it. Note that the Arduino IDE has a built-in compiler which allows us to click the upload button and for it to compile. And you'll see later in the video, I convert this file into hexadecimal using the built-in compiler. So once the object code is created, the source code is not needed or not required for the program to run. Like I said, you can easily redistribute just the hex file. It also makes upload very fast, as it is already compiled and you don't have to, every time you upload it, compile the code. Whereas with, if you were to constantly use the Arduino code, you'd have to verify and upload it every time. Now, on the contrary, we have an interpreter. Languages like Python and Java use an interpreter. What an interpreter does is it converts the instructions line by line, and then it directly executes the source code as it converts it. But it doesn't create the object code. It does that as it goes through and converts them line by line. So you don't get the .hex file, you just get the Python file that it runs directly. So the source code and the interpreter is required for this to run, making the file size a lot larger. And it also generally runs a lot slower, as every time you run the program, it needs to be interpreted. So that's the difference, and you'll come across those when you start to learn more about different languages and more computer science key terms. But for us, Arduino uses a compiler. Next, I mentioned high-level and low-level languages. So on the left, we have the description for high-level, and on the right, we have the description for low-level languages. So like I've showed you, I've showed you the difference. So if we bring up a high-level language, you can see it is a lot easier to understand. It uses terms that we can understand, like output and high and low. However, it does require a compiler or interpreter to translate it into that low-level language, because remember, the computer reads this code, not this code. So we require a compiler or an interpreter. In our case, we're using Arduino, therefore we require a compiler for it to run. Also, as high-level languages require a compiler, it allows us to write code on a variety of platforms. However, on the contrary, because we have this accessibility and versatility, the required file sizes are a lot larger However, less code is required to do more operations. Now the keyword there is operations. Here you can see we've got one line to set the pin mode, whereas with machine code, you can see it requires a lot more lines to do a simple program like this. You can see this program, all in all, it says 37, but it's got some descriptions here. I would say it's about, about 10 lines. To execute 10 lines in low level language, it requires all of this code. So you can see the difference in lines. So if I bring up the next one, let's talk about low level languages. So, as you can obviously see, it's quite logical. It is harder to understand because it looks like gibberish. However, the file sizes are a lot smaller, while the code itself is a lot longer. As we just talked about, it requires more lines to do what a high-level language could do in one line, as we just talked about. However, it also requires an assembler because the computer needs to interpret that language and assemble it together to then execute it. So to recap, what are .ini files? Well, .ini files are source code written in Arduino. They are high-level programming languages that require a compiler to compile it into a low-level language or machine code or object code that can then be run by the microcontroller. So let's go into what .hex code is. Let's do a short recap. So let me bring up the hex code. Here you can see it is object code created by the Arduino. It is a low-level programming language that uses machine code or binary. Here you can see we use hex in the ASCII format. Here you can see it is written in hexadecimal to convey binary data to the microcontroller to talk to it directly. This is what is compiled when we ask the Arduino to compile it. So how do we actually get .hex files? Well, let's have a look. So if I open up a sketch, you can see I've got the Blink example sketch. You can open it up too if you wish to go through with this sort of walkthrough. And then what you need to do is you need to go up to the top and you need to click Sketch. And here you have an option to export compiled binary. So once I click that, you can see we've got compiling sketch. Now for those of you who have uploaded using this option here to the 8BitCADE, you will understand and you'll see that the operation I just did, some of this will look familiar because it's the same way of compiling for a microcontroller. However, we don't upload it to the board directly, we save it to a file. So if I open up where it's just saved, you can see we have two files here and we can see they are in hex files. Here you can see we have one that is just the blink hex test.ino. This is just the sketch. However, we have another one. It says with bootloader. Now that means that when you upload the one with the bootloader, it gives the microcontroller the bootloader as well as the sketch. However, if you already have the bootloader installed, then you can just use the bottom one and then upload that and it will give it the sketch. If you had a new microcontroller, you would want to upload this one first to give it the bootloader, to give it the data and the metadata to, take in code. And then, if you were to upload another sketch, you would want to give it this one to then just adjust the sketch and not the bootloader. So for us, we can actually delete this because all of our microcontrollers come with the bootloader. Thank you so much for watching. This has been Jack Daly from 8BitCADE. I hope you enjoyed this video and I hope you learned a lot. The presentation used in this video can be accessed by going to 8bitcade.com and downloading it. Thank you so much for watching. Keep making.